Hello everyone, in this tutorial I'm going to teach you how OpenFOAM really works. As you might know, OpenFOAM is an open source software and we can use this feature of the OpenFOAM to make our own solvers and own libraries. Even if we don't need our own solver and own libraries in most of the cases, we can use this feature to understand the physics behind the simulations better. In most of the cases, we mostly work in the cases in the tutorials that we already have, but we don't know how is it working inside OpenFOAM in general. So in this video, I'm going to get a bit depth into the source codes that we have. I don't want to make a new library. Maybe in the new video, I will make our own first library. But in this case, in this full video, I'm just going to give you a brief introduction of the OpenFOAM libraries and solvers and source codes. Just before going to the OpenFOAM, I want to give a very brief introduction about the files that we are going to see there. In each library or solver, we have a .h and .c files. .h file are the header files that we define some of our parameters in .h, and then in the .c, this is the important file and the physics and everything, all the equations comes in the .c file, and this is the file that is going to be compiled. But you have to remember that these files should have the same name, so if they have different names, so when you want to compile it, you will hit some error. So just pay attention to this. And we have other folder called make folder. And in make folder, we have two files, the option files and the files and the files. In options, we define all the libraries that our new library, our new solver is going to use those libraries. We cannot define all the features of one library in in the new library. So we should use the already existing libraries in our new library. So we define them in the options. Then in the file, we write our name, the name of the library that we are going to compile, and at the same time, the name of the name that we are going to use later on to to make it recognizable to the OpenFOAM and our case in the tutorial. So let's go to the OpenFOAM and let's see how we can find the source code. We go to the other locations, Ubuntu, then in the OPT, this is where OpenFOAM has been installed. Among all those folders here, I'm just going to focus on the SRC and applications. Others I don't want to just focus on. We also have the tutorials folder that we use it for our cases, that we use it always. And SRCs are the libraries that we have, and applications are the solvers that we have. If you go to application in the modules, you will see all the solvers that you have. But in the sources, we have the libraries that we are going to use. One of the libraries that is very useful, and most of the cases we use it, is the FE model. FE models, or in previous versions, FE options, are the source terms that we added to our conservation equations. Like, I don't know, if you have a Proust media, if you have a rate change, or any other source term that you are going to add is the FE models. If you go to tutorials folder, for example, fluid, angle light, if you go to constant, you will see FE models. Here it uses a Proust media, Darcy shimmer to add a Proust media and add it as a source term to the file. So this is the FE models. If you go to the general, you will see some libraries here. But if you are here, you will see the make file. As I told you before, the make file. We have the files, and you see all the .c file, the files that are going to compile here. And at the end, you will see the lib, the path, and the name of the library that you are going to use. If you are making your own library, you should change this to a new library, to a new name. It could be any name that you want to write, but you should remember this, and then after that you can use it in your cases. I'm not going to change the libraries in this tutorial. I'm just giving you a very brief introduction. And these are all the .c files that is this new folder is going to compile. And if you just look at the name of the file, you will see these names are the same as the names here or here. And the options, as you can see, it uses all the libraries that are already in OpenFOAM to make their new library. So they don't have to define all the libraries in just one library. We can use the finite volume mesh tools from other libraries, physical properties from other libraries, or thermophysical, thermal models, thermochemical, everything that is needed for this library we can use from the other libraries that they already use it. And these are the external ones and these are the internal ones. So this is a make file, and for example, if you go to the phase change, that is most of the cases we need phase change or any other folder that you want to go, then here you will see the .h file and .c files. For example, coefficient phase change .c, coefficient phase change .h. If you open it, you will see a very brief introduction here. Then it defines and it shows how it works, but we don't define any specific code here. Then we go to the .c, which where we define all the equations here to have a phase change, and they have the same name. But here you will see other .h files, phase change.h, phase change.h, or thermoref, pref, paref.h. This is called static header files that when you want to use your .h file, you should include, for example, change.h. So we include all features of the phase change library, which is here, to our new library. So, and this kind of including is called static header files. How we can use it when we want to use a static h file, we should put it in the same folder as this library. So this is how the library is working. In general, I didn't give you very detailed information. If you go to applications, you will see the same. The modules, for example, compressible volume of fluid, then .c, .h, and .c files here. And some of the libraries, I told you, not all the libraries are in the SRCs, but some of the libraries are close to the solver. Like here, you can see other FE models that are specific to this library, and you can use it here. So that's it. That's how it's working in the OpenFOAM, the libraries that we have. So, but in the next video, I will change or make a new library so you can understand how is it really working. See you in the next video.